Okay, class, tonight we're going to solve rational equations. So rational equations are fractions, and it's often with the x in the denominator. So one tip we can do to eliminate all the fractions is multiplying by the LCD. So if we look at our two denominators, the least one in common would be 2x, so our LCD is 2x. So I'm going to multiply the entire equation by 2x, and I'm going to distribute to all of the terms. So when I multiply it, the first term, I get 6x over x, and my x's will cancel. Multiply it by the second term, minus 2x over 2, and my 2's will cancel. And I distribute it to the third term, 24x over x, and my x's will cancel. So I just distributed, right? I multiplied it by 2x, all three terms. It's the same thing as multiplying by 2x over 1. So remember, you multiply the tops of the fractions and the bottom of the fraction separately. I cancelled all of my fractions. Multiplying by the LCD essentially means you will get rid of all of the fractions. So I have 6 minus x equals 24. I continue to solve, so I'm going to subtract x from both sides. I get negative x equals 18, or x is negative 18. So we're going to check for extraneous solutions. We will see a lot of those. So 3 over minus 18 minus 1/2, does this equal 12 over minus 18? So I just plugged in minus 18. Reduce my fractions. 3 over minus 18 is minus 1/6, right? 1/2 in 6. 1/2 is the same thing as 3/6, so I have a common denominator. And I'm going to write that in 6. I'm going to divide the top and the bottom by 3. So it's minus, if I divide by 3, I get minus 4/6. I know it can be reduced further, but I want them all in terms of 6. Minus 1/6 minus 3/6 is minus 4/6. Is minus 4/6. So it does in fact check out. So our solution is minus 18. Let's go on to part B. So for B, I'm going to again multiply by the LCD. My LCD is the only denominator we see is x plus 1. So I'm going to multiply everything by x plus 1, or x plus 1 over 1, and now to distribute it to all three terms. So I have 5x times x plus 1 over x plus 1. This equals 4 times the quantity x plus 1 minus 5 times the quantity x plus 1 over x plus 1. And my x plus 1's cancel. I got rid of the fraction. That's the point of multiplying by the LCD. So I have 5x is distribute 4x plus 4 minus 5. I'm going to subtract 4x to the other side. Combine 4 minus 5 is minus 1. I'm going to check this. 5 times minus 1 minus 1 plus 1. At this point you can stop because we would be dividing by 0, and that is undefined, which tells me that my solution here, x equals negative 1, is an extraneous solution. So we will see extraneous solutions pop up in two ways. A solution that causes us to divide by 0, and we'll also see ones perhaps where they're off slightly, where you get like 3 equals negative 3, but most often our extraneous solutions will represent ourselves when we're dividing by 0. So since x equals negative 1 is an extraneous solution, I'm going to cross it off, and this has no solution. Sometimes our equation will have two solutions, and when we check them, one of them will check okay, and the other one would be extraneous. Okay, so let's move on to C. So here again, we're going to multiply it by the LCD to get rid of the fractions. And if I look at this, I know that this is a difference of squares. It factors as x minus 2, x plus 2. So this, in fact, is our LCD. X minus 2 times x plus 2, or x squared minus 4. Okay, so now I'm just going to multiply all terms by this. So I'm going to multiply the first term by x minus 2 times x plus 2. Write that a little more neatly. X minus 2 times x plus 2. The second term by x squared minus 4, and x squared minus 4. It's the same thing. So in this first one, the x minus 2 cancels with the x minus 2, so I'm left with x plus 2 times 3x minus 2 equals, the x squared minus 4 cancels, so I'm just left with the 6 plus 1 times x squared minus 4. You need to use the box method or FOIL, so 3x squared minus 2x plus 6x minus 4 is 6 plus x squared minus 4. I'm going to combine like terms, so I have 3x squared plus 4x minus 4 is 2 plus x squared when I combine, and I'm going to set it equal to 0. We're always going to set this, it's a quadratic, equal to 0, and then solve. So we solve by how we solve all the other quadratics, so subtract x squared over plus 4x. I'm going to subtract 2, so I get negative 6 equals 0. See, they all have a 2, so I'm going to factor out a 2. Then I can divide both sides by 2. And I have x squared plus 2x minus 3 equals 0, and this can factor. I know it's x plus 3, x minus 1. So x is negative 3 and positive 1 are my two solutions, and I do need to check both of them. I'm going to check. So first I'll check x is negative 3. So I have 3 times minus 3 minus 2 all over minus 3 minus 2. This is equal 6 over minus 3 squared minus 4 plus 1. So I have minus 9 minus 11 over minus 5 to equal 6 over 9 minus 4 is 5. And 1 can be written as 5 over 5, so this becomes 11/5, and this becomes, when I do both negatives, 11/5, so that does in fact check out. So negative 3 checks out, so let's check x equals 1. So 3 minus 2 over 1 minus 2. This is equal 6 over 1 minus 4 plus 1. 3 minus 2 is 1. 1 minus negative 2 is negative 1. So I have negative 1 on the left-hand side. 6 over negative 3 plus 1. 6 over negative 3 is minus 2 plus 1 is negative 1. So negative 1 equals negative 1. So they both check out. So this is an example having two solutions. Okay, D, so we're going to solve this. This also works where we can just multiply by the LCD to get rid of the fractions, but if we have only two terms, you can also cross multiply. So we're going to use that. So 3 times x plus 4 equals 1 times x squared plus 4x. I'm going to distribute. 3x plus 12 is x squared plus 4x. I'm going to, again, set equal to 0 and solve. So I have 0 equals x squared. When I subtract 3x over, I get plus x. Subtract 12 over, get minus 12. So I'm going to factor this, and I get x plus 4x minus 3, and I double check it, and it does in fact factor correctly. So I get x equals negative 4 and positive 3. Those are my two solutions. So I'm going to check. So first I'll check x equals negative 4. Plug in negative 4, I get positive 16. Plus 4 times minus 4. Does this equal 1 over minus 4 plus 4? Here, this is undefined, which tells me that negative 4 is not a solution. So let's check about x equals positive 3. So 3 over 3 squared is 9, plus 4 times 3 is 12. Does this equal 1 over 3 plus 4, or 7? 9 plus 12 is 21, so 3 over 21, is that the same thing as 1 over 7? Yes, it is. So my solution, x equals 4, is not a solution. Only x equals 3. So x equals 3 is my only solution. The solution of x equals negative 4 gave us something undefined, so that was an extraneous solution. Okay, so that is everything about solving rational equations. You have a great night.